When I'm using the product rule, if I have the same base, what do I do with their exponents? Base with the exponents. What do I do with the exponents?
What?
You add them. Very good. So x to the 6th, y to the 7th, and then what do I do with my coefficients?
Multiply the...
Still multiplying, so you get 12 here. Awesome. All right, now here's a tricky one, so please make sure you're paying attention.
I hate this one.
We're going to try and make this as simple as possible, okay? Everything that's under your radical, put it in parentheses. When we rewrite it, it's still going to be in parentheses. So the only thing that I need to rewrite in my first step is my radical. How can I express a square root
2
as a fraction? Not 2.
over 2.
1/2, yeah.
Oh.
1 over 2. Something has to be over 2, right? 1 over 2. So if you want to make a note, the square root is equal to the 1/2 power, meaning the exponent, 1/2 exponent. Now, we've already solved problems like this in our other examples, right?
Yes.
What do I do with exponents when I have an exponent outside the parentheses? Multiply them. So if I multiply with fractions, you just multiply straight across, and we get
3 over 8.
3 over 8. And there's my answer. What would you do if it asked you to write it in radical form?
Oh, put 8 on the 3 on the outside and x to it.
Mm.
Maybe 8.
8 is your index, and you write x to the third power. You could also write it as 8 on the outside for your index and x to the third power. This helps you when you have a large number under the radical to simplify it before you use your power and cube the number. Okay? All right. Moving on to this other example. We're going to do it again, but this time my power on the outside is going to change. So put whatever's under your radical inside parentheses. What power is outside here?
3 and put it over 1.
To the third power?
To the third. The third of it.
1/3 power. 1 over 3. 1 over 3. Okay, when you multiply those, what do you get?
2 over 9.
2 over 9. And that is your answer. And if you wanted to write it in radical form, or if you were asked to write it in radical form, I probably shouldn't use a 9 and an a together, but that's 9. The 9th root of a squared, or the 9th root of a then squared. Either way is fine. This just means you can square it before you take the root or after you take the root. And now you are working on the next 4 problems.
Yeah. Do we put them on the board?
Yes. So the first one, your answer should be x to the 2/15 The second one, you should get x equals 6. The third one, you should get 5 to the 13 over 21.
What the heck?
I'll go through it. And the fourth one, sorry, let me do it in my head.
Oh, multiply. Wait.
5 to the 5/6. All right. So I'm gonna go through the answers. Please be respectful. So those are the.
Can we do the third one first?
We're gonna do all of them in order. Okay. The first thing I'm gonna do is whatever's under my radical. I'm gonna put it in parentheses. The cubed root. What fraction does a cubed root equal? 1 over 3. Good. And then you multiply straight across. And you get 2 over 15. So, you might want to make a note. The cubed root equals an exponent of 1/3. What about over here? What does the cubed root equal?
3.
And no, not 3. An exponent of
1. 1 over 3.
1/3 again, just like this one. So you multiply those exponents straight across, and 1 times 1 is 1, 2 times 3 is 6. So this simplifies to 5 to the 1/6, but it only asked for x. That's why I put x equals 6. So it only asked for that denominator. Questions on the first two?
No.
Okay, moving down here. If you have the same base, and you're multiplying, what do you do with their exponents? Add them. But making them the same is not necessarily a wrong answer. What did you mean by make them the same? You don't know. How do you add fractions? They have to have the same what?
Denominator.
Denominator. So what do I multiply 1/3 by?
7. And then just do 7.
Good. Multiply that one by 7 and you get 7 over 21. So I'm just changing, I'm doing some work on the side here to show that this 1/3 is going to become 7 over 21. And what is the 2 over 7 going to become? I have to multiply each of them by I heard 6 over 21. Would you multiply each of them by? 3. Okay, so you just multiply it by the opposite denominator, right? So this one was multiplied by 7 over 7, and this one was multiplied by 3 over 3. And then 7 plus 6 is 13.
Wait, you don't multiply the bases?
No, because if you had 5 to the first times 5 to the first, and you added the exponents to 2, would you also multiply the 5s?
Fair point.
It would be 5 squared. Otherwise, if you did 25 squared, it would be doing the same thing twice, and you don't want to overdo it. You're over-solving the problem. All right, now, notice my answer's in exponential form. So what do you think I did up here? Did I change the first one to radical form? Probably not, right? This is an exponential form. My answer's in exponential form. What am I going to do? Change the second one to exponential form. So this is 5 to what power?
2 to the 3rd.
Good. Now, remember, you can put the 5 squared inside the parentheses, and the exponent on the outside is 1/3. But we only really have to do that if we're working with fractions, because you know you can put this in the numerator and your index is in the denominator. So we still get 5 to the 2/3 when we multiply those together. And then when you multiply a base, oops, sorry, we're multiplying these two together. What do you do with their exponents? You add them. But I need a common denominator.
Just do the 2 to the third times 2.
Good. Multiply this by 2, and I get 4/6, which gives me 5/6. 5 to the 5/6. Questions on the second two? Okay. So if you see a rational exponent and a radical, then most likely you're going to have to change it to exponential form, because a lot of the times you'll have two separate indices, meaning this index is going to be different than that index. So what I'm going to do is keep my numerator in exponential form and change my denominator so that my index is 6 and my exponent is 3, so my denominator is now in exponential form, 3 to the 3/6. Then I use the quotient rule. And I know that if I have the same base, then the quotient rule, meaning something in the numerator and something in the denominator, means I subtract my exponents. So you have 3/2 minus 3/6. I'm going to reduce that to 1/2. Then that way I have common denominator. And I know 3/6 is the same as 1/2. So I subtract those and I get 3 to the 2/2, or 2/2, which is just equal to 1. So the answer here is 3. Next, this is one of those like term problems. If it has a radical, then you can add them together, but it has to be the same exact radical, and you use it as a like term, so you only add the number out in front. And then if it doesn't have a radical, you can only add it to other things that don't have a radical. So we're going to distribute this negative first, and I get 5 plus 7√3. And then when I distribute that negative, it becomes minus 1. And a negative times a negative is positive, so plus 8√3. Then you combine like terms. Here's the ones that both have the square root of 3. So I'm going to combine those and I get 15√3. And then I'm going to combine my constants, which are my numbers without a radical. 5 minus 1 is 4. And the 15 was positive, so that'd be like 4 plus 15√3. Can you combine the 15 and the 4? No. The 15 has a radical of 3, the 4 does not, so this was your final answer, and you keep it that way. There's a lot of problems that you have to simplify numbers that are being raised to rational exponents that don't even have variables. So I'm going to show you how to do this problem. The best thing to do is to change it to radical form. You don't have to. You can change this 4 to exponential form. What do I mean by that? Keep this same exponent. How do I change the 4 to an exponential form? You can change it to 2 squared. Okay? But the easiest thing to do is to change it to radical form instead. This denominator becomes my index, which means I'm taking a square root. The 3 becomes my exponent, and the 4 goes under the radical. So 4 to the exponent of my numerator of 3. You can write it this way, or you can write it with the 3 outside of your radical. I like this better, and I'll tell you why. These are both square root problems, so I don't really have to write the 2 there. I would rather take the square root of 4 and then cube it than cube the number 4 and then try to take the square root of that. Either way works, But once these numbers underneath start getting really large, like this 32, it's easier to take the square root, which is 2, and then cube it afterwards. 2 cubed is equal to 8. But you'll notice that if you do 4 cubed first, you get 64, and the square root of 64 is also 8. So either way works and you get the same answer. But when we take a look at the next problem, you're going to want to factor out that 32 first and then deal with the exponent afterward because it's such a large number. So let's take a look at that. I'm going to change this to radical form. I have a 5th root of 32 raised to the 2nd power because that's my numerator. Now, when I raise it to the 2nd power, I'm going to do that after I take the 5th root of 32. So 32 breaks down to 8 and 4, 2 and 4, and then each of these are 2 and 2. I need 5 of any prime number in order to take it to the outside, or any number at all. 5 of any number, in this case they are prime, and I don't have any other prime numbers left over, which means I factored everything and it's only these 2's at the end. Since I have 5 of them, I can bring out a 2, but because there's nothing left to be factored, this radical disappears. So I have a 2 and I raise it to the 2nd power because I'm dealing with this exponent at the end. So the 5th root of 32 is 2. 2 squared gives me 4. So your answer, just kidding, this part is equal to 4. So I'm going to write this as 4x to the 6 over 5. So this is an equivalent expression. You can also simplify, you can write this in radical form. I'm going to show you some different ways that how this would look if it was switched to radical form. Radical form would be 4 and the 5th root of x to the 6th. So that's correct as well. You could also factor this out and get 6 x's, and you can get one group of 5. So one of the x's is going to come to the outside. But since we started with 6 and I took a group of 5, took one of them out, then that means I would have one left over on the inside. So this is also correct. So you'll see different ways to write this, and you might have different ways of simplifying it, but you want to just make sure that your denominator is your index, your numerator becomes your exponent, and you can either write it inside of the radical or outside the radical. So you could write it like this as well. They all mean the same thing.